Okay, we are going to look at different families of organic chemicals. Now, organic chemistry uh, is, uh, concerns compounds which contain the element carbon. Of course, carbon always forms 4 covalent bonds. That means it can form covalent bonds to other carbons, which gives rise to a huge number of compounds carbon can form when compared to other elements. So let's first look at these molecules which are drawn in black here. These only contain carbon and hydrogen only, and they are called this family is called the alkanes. There's so many compounds in organic chemistry, it makes sense to group them into families of molecules which behave in very similar ways. So here's the alkanes. They only contain carbon and hydrogen. This one you probably know is called methane, and that is CH4. This one is called ethane when you've got 2 carbons, and that's C2H6. When 3 carbons along, you would call that propane, and that's going to be C3H8. Then up to 4 carbons and 5 carbons. 4 carbons long, we call that butane, and that's C4H10. That's all you need to know to GCSE actually, but I've also put this one in here. This is pentane. It's quite easy to remember the name, pentagon, pentane, and the next one will be hexane, heptane, octane, and so on. So that's C5H12. Okay, so the alkanes, you probably noticed that they've all got similar formula, and we can simplify that formula to CnH2n plus 2. Okay, now the next group of molecules, we've got these ones I've drawn here in blue, and these are called the alkenes. Now, like the alkanes, they only contain carbon and hydrogen, but the difference is that all of the alkenes contain a double bond between 2 carbons, which of course you can't have an alkene with just 1 carbon in it, because you couldn't form a carbon-carbon double bond. Okay, so this one is called ethene, and that would be C2H4. This one would be called propene, which is C3H6. So you can see already the formulas, the general formula is a bit different. It's CnH2n. Okay. Now, having that double bond makes them behave fairly differently to alkanes. They're more reactive, they're more interesting. Alkanes really don't do much apart from burn, whereas alkenes can undergo, that double bond makes them undergo various different reactions. So they are a different family, and they've got different characteristics. Okay, and the next one along here we've got is butene. Now you can probably see that there are actually 2 possibilities of butene that you could have. I've only drawn one there. This one here, we've got the carbon-carbon double bond here between those, and you'd call that one butanene. You could also get rid of that double bond there and put it there instead. It'd be a very similar molecule, but not quite the same. That would be called butene, but you don't need to know about that by GCSE, but just so you're aware that there are 2 slightly different versions of butene. And if we have a look at pentene here, again, there are 2 versions of pentene. You could have, that's pent-1ene that I've drawn there, but you could also have the double bond, in this position here, which would mean it would be, you'd call that pent-2ene. Okay. Obviously, if you put the double bond there, that's just the same as putting it at the other end. It's just the molecules flipped around. So that wouldn't actually be a different version. So that's pent-1ene. Now let's get on to these red family of molecules here. Now these are called the alcohols. And what we say, the alcohols contain this OH group here, and that's called the functional group. It's called a functional group because that's what makes the molecule behave in a certain way. The carbons and hydrogens, they don't really do anything. They're just kind of an inert skeleton, really. They don't really do much. And the functional group, obviously, in alkenes is the carbon-carbon double bond. And alkanes, well, they don't actually have a functional group. It's just that carbon hydrogen skeleton. Okay, so anyway, the functional group is going to be the OH, which you find in every single alcohol. Now this one here is called methanol. Now you can write the formula as CH4O, but it's probably more common to write it as CH3OH to show that the oxygen is stuck onto a hydrogen there. That's methanol. Now the big difference you notice there is if you look at methane is a gas at room temperature, a very low boiling point, minus 160 or something, whereas methanol is a liquid and it doesn't boil till it gets to 70 degrees C or so. So having that OH group really changes the physical properties as well as the chemical properties of the molecules. Okay, and all the alcohols, they're all liquids at room temperature. Okay, so let's look at the others. The next one with 2 carbons long is called ethanol, and that is the alcohol that is found in drinks, C2H5OH. This one is called propanol, C3H7OH. And then we've got, you probably noticed there that the alcohol group, the OH group, here it's on carbon number 1, so that would actually be called propan-1-ol. There's another version of propanol called propan-2-ol where you put it on that carbon there. Again, you don't really need to know that for GCSE. And they are very similar molecules, but they're not exactly the same. They're a little bit different. Okay. Then we've got butanol. Again, you can have butan-1-ol, butan-2-ol. And finally, we have got pentanol. So I'll just complete the formula there. So that's C4H9OH and C5H11OH. Right. The final family of molecules I'm going to talk about in this video are these green ones. Okay. And these are called carboxylic acids. Okay. Now, these, if you look, they're similar to alcohols because they contain this OH, right? But they also contain a carbon-oxygen double bond. And so it's this bit here. This is the functional group for a carboxylic acid. Look, that one there's got it as well. You need the carbon joined onto a C double bond O, and you need an OH stuck onto it. Now, carboxylic acids, they are all liquids at room temperatures, like alcohols, and unlike alkenes and alkanes. They smell different as well. Okay, so this one is called methanoic acid, and they tend to smell not very nice. Okay, so this one is methanoic acid, and that's a sort of a irritating sort of sharp smell to it, whereas methanol smells quite nice and solventy. This is ethanoic acid. Now you recognize the smell of that. If you ever smelt it, you'd probably say salt and vinegar crisps, or it is the stuff that makes vinegar taste like vinegar. It's so vinegar is a dilute solution of ethanoic acid. And then we get to propanoic acid, which smells horrible. It smells of like sweaty feet, a slightly cheesy smell to it as well. And then finally butanoic acid, which smells of vomit. And one more, 5 long, pentanoic acid. I'm not actually sure what that one smells like, but it probably doesn't smell very nice if it's anything like the other ones. Okay, so these molecules all behave differently to the alcohols. They're similar to the alcohols in some ways, I suppose, because they're all liquids at room temperatures, but having that carbon-oxygen double bond makes them behave quite differently. And let's just look at the number of bonds there. So we know oxygen always forms 2 bonds. So you can see the oxygen here, that's forming 1 double bond, that counts as 2. And that oxygen there is forming 2, 1 to the carbon, 1 to the hydrogen. We know that carbon can only ever form 4 bonds. It's always got to form 4 bonds. So that means because it's using 2 bonds up there and 1 bond up there, and it's only got 1 bond left. So that means the carboxylic acid group, this group, can only be found on the end of a chain. You couldn't put it on this carbon here because that carbon there is already forming 3 bonds, and you can't have that. Okay. So that they are the 4 families of molecules that we need to understand need to know about for GCSE. So we put them all together like that. Okay, so you've got the alkenes, the carboxylic acids, do that. The alkenes, the carboxylic acids, and the alcohols. These families are sometimes called, the proper name for them is actually, they're called homologous series. Anything with the word homo in it means the same. So it's the group of molecules which all behave in the same or similar ways.